It's currently the same as this. So I'm currently having a sinus here. Let's see if I want to commit this or the 4-degree thing. So yeah, sinus. So first, with 2 points, we have this approximation, which is a parabola. And yeah, that only has a maximum, so we just continue in the same direction. That is downhill. Now we have, with 3 measurements, all super close, it already sees that's not a parabola. So it now made a 4th degree polynomial is approximation. And now next we should jump to this minimum, because that's the lowest minimum. But I didn't implement that yet. Well, in order to find this, I have to calculate the zeros of a 3-dimensional polynomial, namely the derivative of this turquoise thing, and then we found that minimum and that maximum, this minimum. But I'm not doing that yet. And I'm thinking about not doing it at all. So in fact, I'm continuing as if this is a parabola still, even though it draws the 4th degree thing. And that means that it's still going just downhill, because the parabola is still being drawn like this, really, and there is no minimum. You see now, you see it move. It goes faster and faster, very slowly. Okay, finally it's really dropping. And now we are overshooting, so now it goes back. And then we found the minimum here with parabola. Okay, we'll do one more step. Now it should be possible to know that this is super close to the actual minimum. You can, for example, see that because the value hardly changes anymore. I can even do one more, and then it really hardly changes anymore. So now I found this as a minimum, which then means that I can do, hey Ninja, I can do a polynomial division of the 3rd degree polynomial that is the derivative of this thing, with x minus the 0 that we found here. And then that should have a remainder of 0, and then we get just a simple parabola again, which then has which then shows us actually 2 other minima. I guess that parabola will have a 0 here and there. Yeah, and then tough decision. I mean, there are other minima, but they are not really lower than this one. It's just a sign, so. I think that what I want to do now is to jump to the maximum here anyway. And then, yeah, have another approximation. I think that at this point, so then we get actually this point here, I will see this one already. So then we can saying, okay, we misjumped, the actual top is there. And then, yeah, you could just pass this top, then you see that minimum. But that minimum is not lower than this minimum, but yeah, I don't know. Maybe it drifts. I don't know what happens. I mean, just every minimum is the same. in this case. Okay, anyway, that's the idea. So the next step would be that I need to do a long division. Let me think. First I'm going to commit this. No, I'm not using that. Oh, I'm using that. No, I'm not using that. Why am I even linking on that? Dude, I'm so confused. Pretty sure I'm using eigen. Let's link with eigen. Maybe OpenBLOS is simply finding eigen. I don't know. No, still the same. Okay, get diff again. Good, let's push it. Maybe I can just add it to this test suit, eat something. Why are you sleepy? How late is it? I'm not sure if you said 3.5 hours, so are you 3 hours ahead of me or 3.5? Bedtime. You should already go to bed. You were going to bed at 11. 18 minutes past bedtime. Plus 5? It used to be 3 hours. What? How can it suddenly be 5.5 hours? Yeah, then you can only watch my streams if I stream in my afternoon. And it's already almost 8 p.m. here. It's already evening. Yeah, let's make some polynomial. All my expressions are expressional stuff. Polynomial. I have an x, I guess, so let's just make a polynomial. How can I do that? Okay. I'm not even sure I have all those symbols. I don't think I have a W. I do. I have a W and all the way up till H, so these things exist. So it just prints it like that, which is not very useful. We have to assign certain values to the coefficients. So let's say, no idea, man. Anything goes, right? Let's make this one negative. Now, is there a way to still print this thing, but now using the evaluations of the coefficients? Not really, actually. I can evaluate the whole thing, but only if I fill in some value for W. Yeah, I don't know if this is the right direction. Maybe I should write a separate something instead of using symbolic. I can assign values here, but I just keep seeing these things as arbitrary symbols. So doing a division is not making things very much simpler. Yeah, I don't think I should use symbolic actually, so forget about this. I'm going to look at gradient descent, or add it. Let's add some stuff here, if I could type. Yeah, let's make a complete new class, I suppose. I'm just gonna call it polynomial. I'm already having an array of coefficients here. That comes very close to what I need. So this could be a polynomial. And then coef is used here, assign values to certain coefficients. I guess this is an evaluation then. Evaluation at W. Yeah, it could be added to the class as well. Yeah. Good. So okay. So basically, vector. It should be a vector about a wrapper around a vector of double. I'm gonna call it polynomial. Put it at the top. Polynomial. Private. Nope. I thought I copied it, but no. I don't want to keep this. I put all that effort in it. Let's keep it for now. Coefficients Did I write that correct one? Yeah. It's not the namespace. Yeah, can assume that it's already included somewhere. Let's give the thing a name. Separator. Some for loop. Okay, so we store these from, yeah, let's say the index is equal to the exponent, reasonable. And I want to print them like this, so the exponent is rising. In other words, we just print them in the order. in the same order as they are. I could run over the exponents maybe. No, this makes more sense. Run over the elements of the vector. Exponent is just for printing, and I'm not really doing anything with it, I think. Anyway, the exponent starts at 0. No, I think there's one thing missing, but let's make a polynomial called, well, not coefficient, but polynomial maybe. No, I could call it approximation. I already have approximation though, but I think I'm gonna move that anyway. Approximation. It's no lambda, isn't it? Yeah. The lambda should be moved to the polynomial as well. So I could call the polynomial approximation. Which is just a wrapper around the vector now. This vector. And then here we can set the elements directly anyway. a custom and Kotaro. Just coding, just coding. Well, I worked a lot in the description, so if you read that, then that should enter it. Oh, wait a minute. That's not going to work. Let's set the so this is to be moved to the polynomial class, and then I use it here, and I guess I pass it to solve here. Yeah, and that should still work. I just have the polynomial now should take the place of this lambda as well, so I turn it into a functor. So the thing returns a point. Strangely enough, I have to admit. Now it's a functor instead of a lambda. Operator. And this is reverse because, yeah, we have to start at the highest coefficient. Otherwise, this algorithm doesn't work. Let's not use abbreviations anymore. Coefficient. And then I had a symbol name for the printing, yeah, whatever. Yeah, directly after doing this is just all zeros. Just wait until I actually have assigned everything, including the last one. So let's see if this compiles, and it still does the same thing. To be honest, I'm not super happy that it returns a point there. Is that really necessary? So the reason would be because Solve is using it? What? Of course it doesn't. Approximation fitter. Okay, that takes points, yeah. But I don't want to load my polynomial with it. So instead of returning a point, I'm going to just return the value. The result value, which is maybe lame, but at least, yeah, then I don't have to think about the point anymore, at least. So we just return a result here. And then we can't use approximation anymore as the functor, because we need something that returns a point. So let's see. So instead of passing approximation, then I'm gonna pass a lambda, which takes a double, which is W, and that thing does return a point. Let's put this on a new line. Yeah, so this is a lambda which takes a double as an argument and returns a point. And we implement that as return, and then just two braces for the constructor of the point. Where the first argument is just a W and the second is then the return value of our polynomial. Yeah, and then of course it's no longer a point, so now this is just without the Y. Approximation cannot be implicitly captured. Yeah, this lambda is now using approximation, which is a wrapper around a vector. So let's capture that by reference. I can just explicitly state that we just capture approximation by reference. Expected semicolon after return. And then with all the typos out of the way, it will compile and do exactly the same thing as before. Or not. Oh. So much for using this tree. So yeah, assign this and then ding doing ding dong ding 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 dong ding doing 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 doing. Exact same thing as before. However, it does something extra. It prints now the value of the approximation, so you can see what it thinks that it is. Yeah, so initially we start with a linear function, and then it approximates it with a parabola, and then it approximates it with a fourth degree polynomial, and it stays like that. Hi, postman. I read Scatman and Go Carlo from Post Bunny at the same time, and I reply. Hello, postman. What the fuck? Hello, post bunny. Okay, so at some point, yeah. At some point, I want to long divide the derivative of this polynomial. And not this polynomial. That would be Christmas. The Christmas man, or is that not? My brain is completely confused. In Dutch, Santa Claus is called the Kerstman, aka Christmas man. But in English, there's no man at the end. So the joke didn't work. Yeah, slight problem there. In the end, I need to do a division of the derivative. Sorry, I have to think. Let me think. Yeah. I'm thinking if this it's not too slow, can I not go directly to the derivative? Then I can't draw it anymore. The thing is, of course, that I'm calling this. I'm calling this here to solve a matrix equation. That gives me directly the coefficients of that polynomial, but only because I defined the matrix like this. So we define the matrix differently, it would directly give me the coefficients of the derivative, I guess. Yeah, I'm going to stick with this at the very least right now, because this is just optimization then. And I want to draw it anyway, so it's nice to have the polynomial so we can draw the approximation. But yeah, I do need the derivative because we need to find the zeros of the derivative. So let's add to my class a function that returns the derivative. That thing then must be initialized with the number of coefficients -1, I guess. and then the coefficients are filled with yeah, now I'm using I. Okay, let's use I here as well. CoF is an abbreviation to begin with. Okay, I'm feeling stupid, but let's type in an example. For example, I have function w, which is equal to 3 plus 2 times w plus 5 times w squared. Then the derivative is 2 plus 10 times w. In other words, it is the first coefficient is the second one there times something, I plus 1 times something, and the times equals to the exponent of that thing, which is equal to the index of that thing. So I have to multiply times I plus 1. Now I'm edit. I want to print the thing. Print. The nonsense of it all. I'm pretty sure we are a friend of the thing, but I might as well use coefficient size minus 1. Okay, it has been decided. This runs from 1 till that. So I can make this an I, and this an I. This is an I minus 1, and that is just simpler. Compile, damn it! Oh, I have to put my PC closer. It's standing on the ground here, but I can't kick it. Okay, that was my fault. But I kicked my PC anyway. Hey, it did compile. That looks not good. First of all, it should start with a straight line. Yeah. It's immediately a parabola now. Very strange. And it's not improving at all. What about my derivatives? Looks good. The derivative seems to be okay. Oh, I changed the name to an accent. It's of course not true. Haha. Yeah, nonsense. They should use the same name. It's the same symbol. But otherwise... So why is it suddenly not working? Okay, now I'm confused. Did I test this thing not just after I finished the polynomial and it worked? Because I suddenly cannot remember anymore. I think I don't it worked. I thought it worked, and then I added the derivative, and now it stopped working, which is doesn't make any sense. Now, after adding derivative, why would this change things? No, it's a straight line. Yeah, this is exactly how it should behave. It just starts with a straight line and then a parabola and so on. And now you're telling me that if I add this, everything gets fucked up? How the hell is that possible? It's even const. It's impossible. Impossible. Yep. So those two lines screw things up, and nobody understands why. Approximation is oh, okay. So if fourth degree is, well, this thing is no longer 0. There must be a buffer overflow or something somewhere. Okay. So calling derivative causes memory corruption, I think. How? No, I don't see it. Could be coincidence, because adding this changes the program a little bit. And that then could cause the corruption, or make the corruption visible, while there was already a problem with the program. But I really don't see why this particular function does anything wrong. No. Unless I'm completely mistaken in how this works. Really? It's the second time I do that today. Just forget to add the increment. No, it's not crashing, so that worked, but still this weird value here. Impossible. This is completely fucking impossible, man. No, it's a straight line. How the hell is that possible? So we run it in a memory corruption test tool. Everything works and there is no problem. And if you run it outside of it, it stops working. Well, I guess even that is possible. Valgrind is just not catching it. Which is problematic. Okay, so I have somewhere memory corruption, but that doesn't happen if Valgrind is running. It should be somewhere in polynomial itself, I think. Well, I can find it with GDB, I think, because I'm already asserting that it is 0. And then later on, it turns into a non-zero value. Just, yeah, let's use GDB to find this. Okay, where do I have to be? I don't know, this one. Let's stop it here. Line 44. Oh, big vector. What the hell? Number of coefficients. What the hell? What? 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 Of coefficients should be. Number of coefficients is not. What? But it is arbitrary. Wait a minute. Oh, yeah, bug in Valgrind. It should have detected this. Well, that's really weird, man. So I'm not initializing this value, random value on the stack, and then I'm using it. And Valgrind doesn't say, hey, you're testing something that wasn't initialized. Weird. So I need to initialize it to 0 or something. Otherwise this is not done and therefore it's never initialized. 2, 3, 1. Yeah, right now it works again. That was it, I guess. No idea why Valgrind didn't catch that. Why not? Strange. Anyway, let's do a long division by, well, let's just divide it by whatever 0 we find to begin with, which is here, which looks like, I don't know, is it printing that? Yes, of course it's printing it. To this value. So we can ask for a derivative, and now I ask for a long division, which also returns a polynomial. The z of 0. Yeah, we don't have a W really, but I'm calling it W here as well. I just stick to the W. Just like the derivative, it's one dimension less, 1 degrees, 1 less. Okay, how do we do that? Guess I also need some kind of example here. So this coefficient is just the same as that one, where the degrees one less. And then the next one, come on, it is easy. Why don't I see it? What? 2 times that. Okay, yeah. Okay. I think I want to subtract here. This times that. So the W times that is just this thing. And then we get the minus 2 times that. So this is plus minus 2 times 3 times W squared. And if you subtract that, this becomes obviously 0. Should I subtract it? Yeah, of course. So that becomes 11, right? 5 minus 6, minus 6. So then the next term is 11 times W. Plus 10. Okay, so then we do, let's see, remove the trivial 0. So multiply this with the, multiply this with the W. Gives again 11 times W squared. And then the minus 2 times that is then again minus 2 times 11 W. Is it? Subtract that, and then we get 4 plus 22 is 26. Plus 10. And then you get therefore here plus 26. And then we have a remainder. But I don't care about that right now, although maybe what happens if we continue with this, then we get 26 times W, of course, plus, and then again the minus 2 times 26. Do we see a pattern? 10 plus 2 times 26, it is 62. So that's the remainder then. Yeah, the remainder is always a constant, so I might as well return that here. So I want to set, we calculate it in this order, so we want to set it in that order. It's quite logical. So I want to first calculate and set 3 and then 11 and then 26, which means we have to start at the highest one. And this being index 0, index 1, index 2. While the number of coefficients initially is 1, 2, 3, 4. That doesn't make any sense. It should be one less than this. That 3, however, comes from, so I'm going to do the same trick as here, I guess. Just run from the highest coefficient of the current thing. So we begin with the coefficient that contains this 3. And I have to copy that to one exponent lower. So ignoring the rest, that would be a simple copy. Like that. Yep, I minus 1, the coefficient of I minus 1. This coefficient becomes coefficient of I, which is 3 at that point, or yeah, 0, 1, 2, 3. And then the next one is this 11, which is a copy of that 5 as well. I'm thinking this is a kind of a special case, the first one, so maybe I should start the loop one later. Or not, I don't know. It's a minus. So this minus, that minus, and the z is no minus 2 here. Now I have to multiply it with this 3, which is later 11 and then 26, which is actually our output. So the next time we'll use the previous value that we just filled, and I is 1 less, so that would be result I then. The I gets less and less, so 1 higher is already filled in. But I can't access result I the first time, unless of course I make it larger, but let's not do that. So this would work if I start at -2. And then I pre-fill result coefficients -1 with coefficients sorry. Yeah, so we fill coefficient size -2 first, and then we fill coefficient size -2 -1, aka -3, and then -4, and so on. All the way up till I is equals 1, must at least be larger than 0. So then we fill the 0 index. So I'd say this goes wrong if this is not at least 2. If this value would be 2, no, at least 2. If this value is 1, then of course this would be undefined behavior. And this is a negative, definitely not even larger than 1. So we don't have anything here, huh? So if the number of coefficients is 1, I'm not going to consider less. Then that is the remainder, period. Not even this should happen, I think. But yeah, well, you never know. Well, then the remainder is equal to the only element in coefficients. And yeah, actually, if it is equal to 1, then this one is empty. Which is not nice. Definitely not nice. I think I don't even want to return that then. Let's return an empty polynomial, but still with the size of 1. So just 1, right? And then the bloody name still in it. Can do that even before we do this. So now it's at least 2, therefore this size is also at least 1, which helps with keeping that true. And then we do our thing, this works because, well, size is now at least 2. And this would be our long division, I think. Okay, so now I can implement this, maybe. I want to get rid of the whole learning rate though. There is a learning rate, but this artificially changing the learning rate is not the right way. What I want to do is just tell it to go there. So it's more like use this W value the next time thing. So maybe I should not change the learning rate. Yep, what to do here, what to do. It's a bit artificial, you know. I'm setting a learning rate here such that this becomes the W, where the parabola has a minimum. But I might as well just set W directly, I think, and then not do this. Let's try that. No, this is say if keep going, whatever. Just going downhill, you know. So then here, what I really want to do is this, where the learning rate is the new learning rate. Surely I just can calculate directly what a minimum is. Yeah, sorry for how slow this is going, but difficult. Let's have a look at the readme that I wrote here. Yeah, I'm not going to call it the learning rate. I'm just going to call it inverse beta, and then use this formula. What else can we do? I don't see a faster way to know what the minimum is. Or do I? Okay, experiment. Let's multiply this one with W0. And this one is W1. And then subtract that, or let's subtract it like that. And then we get W. W1 times that minus that equals, and then this drops out against that one. Yes, so let's take WM outside of it. Yeah, let's inverse this one. Yeah, then I don't know what the sign is, of course. Yeah, well, it looks more symmetrical, but it isn't really symmetrical anyway because W1 is closer to the minimum, so it's more prevalent. Plus, I need to know the sign of beta. So I think I'm gonna use this instead. I'm not going to do this anymore. I think it's just the wrong way to look at it. Your W is W1, and then the previous, from the history you can get the previous W, which is then obviously W0. I mean, we're going from 0 up. So 0 is the previous one, the one before 1. And we divide that by, and then again, yeah, the derivative of L with respect to W is then the 1. And the history of that is the 1 at 0. So this is the inverse of beta, and then I can just test the sign of that. Yeah, and this was just a copy, so I'm gonna keep it a copy. Verneu. This should not make any difference. Huh? So that means that we're having 5 coefficients, and we just continue. the same way, I think, until I found a minimum. Well, initially I have to do that anyway. So then I have to decide when this became a minimum. Well, that is the case when what we subtract here is infinitesimally smaller than the W itself. At least a lot smaller. It's not true, huh? Is it? It's not true, it's not true, it's not true. I have to look at the change, not the absolute value of W. The absolute value of W can be anything. It could be 0, in which case this could be infinitely larger than W, even if we are subtracting 10 to the minus 33 from it. No, instead I should look at how do you know this is a minimum, but nothing changes anymore? I mean, let's say W is 0, exactly 0. Well, it can't be because I'm still adjusting it. Okay. If this is exactly 0, then we are definitely there. But let's say we never get there exactly. I just get there exponentially fast. Let's say, well, I'm not waiting. I don't want to wait until this is 0. I want to wait until it is close enough to 0. The question is, what is close enough? I think I have to look at the deltas. It's not easy. This is not easy at all. Yeah, I don't think, I don't think you can't know. I mean, I can just zoom in infinitely at the minimum and then say, hey, we're not there yet. So you have the whole valley is just a parabola. The parabola looks the same at any distance, more or less. I mean, just a parabola. So when are you at the minimum? You don't know. I need some external measure to tell me what is small. Yeah. I think we're talking about, in the end we're talking about actual weight, so maybe I could just say if this is a 1/1,000,000th, then it's small enough. But while testing, that is very arbitrary, really. I could, of course, I can use the graph itself. So I have a W max and min. So 1/1,000,000th of this thing, yeah, then we are definitely there. Yeah, I don't know. Maybe that's the only way to go here. So let's just do that right now. So I'm gonna say if no. Let's see one that is reached. That was a little bit too fast, if you ask me. Yeah, I don't think the minimum is reached yet. But maybe it didn't roll the last one. Yeah, it's a sinus, so the L max min is 2. And I'm drawing, I don't know, 120 wide apparently. And then the change is 100th. Definitely does not look small enough. Come on. Definitely not small enough. So like 2 it should be 2 divided by 120 divided by 10,000. And we did not reach that at all. No, it should be around 1.7 millionth. which is not reached. The code is wrong. Huh? Calculator. Okay, now please look the other way. That's one thing. But even then. So in this case we could have, well, it was 1000, I think. So 2 divided by 1000 divided by 120. Did not reach that. Did not reach that at all. Why does it not make any sense? Why? Let's try this again. Just pretend it never happened. Looks like it's just testing if this is less than 100. What does that make no sense? Must be doing something so stupid. Ah, yes, I see it. Finally. Yeah, it is stupid, I know. But why did I see that? Unbelievable. Yeah, that was really stupid. Okay. Brain fart. Still not there. Now we are there. And this is indeed 1/1000th or something. Poo poo. Oopsie boops. So now Now I'm convinced that this works. Yep, we have the minimum reached, and then do I have my derivative already? Yep, I have a derivative. I could get a new polynomial now. That is the derivative divided by w minus this minimum. So O to diff, I don't know what the term for that is. Actually, I do. Let's find it. Or not. Quotient. Yep, quotient. The quotient is then our derivative divided by, and I've got how I call that. I thought something along. Yep, long division. And then z0, which is w, and I will get a remainder back as well. So double remainder. Now, I'm very curious. So this should be an parabola again, right? It's a fourth degree polynomial, and we take the derivative of that, and then we divide it by w minus some 0 that we just found. And then the result should be a parabola. So minimum reached. Yep. Totally very accurate. No, really. Is it true? I didn't even know that it did fit in a double. E to the 10 to the power minus 310. A Planck constant. Planck turns is in his grave, probably. Okay, the quotient is yep, it is a perfect parabola. Cool. Now I can calculate. We can easily calculate the zeros of this thing, obviously. And then I should get these 2 points, I guess. And then we have pick one. You have to pick one. Yeah, it doesn't matter. It's, the whole thing is symmetrical. There is no decision possible. It's like literally turning things upside down, right? Now I want to find this maximum now. For that one. So we're no longer looking for a minimum, now we're looking for a maximum. Okay, and there's about, I don't know, a little bit more than 70, 22 or something. What happens if we just say that we found a minimum way sooner, as in 100 times sooner? Nah, it's already I found it. No, maybe 1/10, I don't know. Inaccurate. No. Same results. I think this is one step sooner. Yeah, this is of course very steep. I'm comparing it now with this line from corner to corner, and then 1/10 of that. So that is, well, not entirely horizontal. Or maybe by coincidence it's like, but this is the same thing. What the fuck, dude? This is ridiculous. Ridiculous. Try something else. This is like really inaccurate. Nah, it's too inaccurate. Let's make it right. Okay, I don't think my remainder is being filled in at all. Because this is laughable. Let's have a look at the remainder. Oh no, and indeed it is not filled in at all. I'm an idiot, damn it. Okay, how do I get my remainder here? Is 62 is the remainder, isn't it? Yeah. So we fill in the 26. Here's the last one. I think the result 0 is 26, and I still have to return that minus w times that value. Yep. No, it already reads on, well, we're there. That's good. That's what I want to see. And the remainder is 12. Okay, that's shocking. That's definitely shocking. I mean, on a scale. No, that's not true. I think the remainder is, well, actually, it is vertical, right? We go from -1 till 1, and then we're off by a factor of 12. Gotta be kidding me. Nah. Oh. Okay, now what? 12. That's like way too big. Unexpectedly big. Or isn't it? Yeah, I think it's too big. This should be considerably less than 1. A bit surprised though. I would say that if you are like more or less in this minimum, then yeah, you get more or less the right solution. I mean, it should be the case, because otherwise it all seems a bit nonsense to me, really. Maybe I should just print zeros to see what those are. The whole thing looks so weird. See how small this all is. Okay. Let's print the zeros. Guess I can just construct a pair from two doubles. Where's my formula? Oh yeah. Standard utils. I'm ahead of myself. Just kidding. Wait a minute. My A is the highest, so that's actually this one. So I want this to be AC, it should be 20. I want a name. What do I call minus b divided by 2a? Yeah, nice is that. The only reason I can think of is that just the remainder was way too big, so we're indeed way too inaccurate. The thing doesn't even have zeros. Ugh. Deep, 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 deep. Minimum reach again. No, what the hell? We're not there at all. Still? Maximum accuracy. Did I just make the mistake again that I didn't have an absolute value? I think that was probably a problem. Horrible. Yeah, well, a more accurate zero can not reach. The remainder is still 2.8. Yeah, no way. No way. Impossible. Although. Jesus, man, the whole approximation keeps changing drastically. One is 10, one is 10 still, and then plus 4.5. What? So what a big change. What an incredibly big change still. Yeah, it doesn't matter. I think the remainder is still unexplainable, if you ask me. I really don't get it. Maybe you should plot the derivative. See where the zeros actually are. Okay, so now we are more or less in the minimum. And this is the derivative. And that crosses the 0 here at the moment that this thing has a maximum, which is the approximation of the sign. And it crosses here again. And it crosses, most notably, of course, exactly there, which is, well, I don't know, I think it should. Okay, that's weird. I would say we're one step ahead, I think. Have we already adjusted? It's crossing, oh, man. It's crossing here, and which is the actual minimum, which does not correspond to this plot here. So I think I'm drawing something that belongs to the next plot. Probably. So let's hit space again. And you see that almost nothing changes. At the very least now it is indeed at the actual minimum is where it crosses. And then this one crosses here. Yeah, that is the maximum, right? So now we found this 0, and this is a third-degree polynomial. So if I divide this polynomial by w minus that 0, we should get a parabola that still has zeros there and there. We've been in the minimum too long now. I think the whole history is exactly in this point here, more or less. Then we get floating point round of errors. Or, I mean, it just doesn't approximate the sign anymore. Except in this very local area, which is not good. It would be better to use the minimum and, I don't know, this point and that point or something. It's not good to have them all three very close together. But obviously this thing still has zeros there, which is the somewhere up there maximum, and a 0 here, which is a maximum up there, and a 0 here, and I for some reason can't find these two zeros. So I'm also going to plot the parabola, I guess. Guess my long division is failing. Let's not wait for the minimum and just non-stop print these things. Oh, that's got assert as well. Can't do that unless it is already. Yeah. Oh, not asserting. No, never mind. Okay, so now we have 1 point, and this is the approximation, which is a linear thing. So the derivative of that is a constant, which is with a negative value. And then if we divide that by the 0 that we found, the 0 of what? I think the 0 of this, that gives us a remainder of 0, because it's just exact. So that makes sense. Now what do we have? So now I have a parabola and then still a straight line, but now with an this is the derivative of that, right? Yeah. This is a derivative. Sorry. This teal thing is the approximation. And then this is the derivative of that parabola. And then if you divide that by the 0 that we found, well, we don't find the 0, but if we assume that this is the 0, the p here, divide by that, you still get something that's almost 0. I have no idea what's going on here. The next one. Okay, this is I have a need for different colors. Fuck. The purple wasn't very clear. It's not really different. I think the magenta is definitely visible. So magenta for the derivative, and then the quotient is no, blue. Why not? As long as you can see it. Hello. About off. Yeah, I can explain, sure. You can do mathematics a little bit. Like if I say polynomial, are you still there? I'm gonna go to this one. Okay, so yeah. It's basically has to do with machine learning, and I'm trying to find the minimum here of a rather arbitrary function, one-dimensional. The function is this one. It is a sine. It says here, sine of some constant times our variable w. W is horizontal and the sine is vertical. So you see the sine here. This is 0 and the sine is 0 at 0. So yeah, the sine starts here in 0, 0, and then it goes to 1, and then and so on. Now we start at the random point, more or less. I dropped it here at 20 point p. And then it determines, of course, the slope. And then normally it says, well, you know, the gradient descent. So this is a hill, and we go down, downhill. So this direction. So it does carefully a little step in that direction, and again and again, and it's like, my God, this takes a long time. It's still going down. So it's accelerating. It's going faster and faster. But after every step, it has a new measuring point, and it measures 2 points. Both the height, of course, just the actual value of the sine, as well as how steep it is. So the derivative. Now, the derivative of the sine is a cosine, but what I'm drawing is the best approximation locally as a 4-degree polynomial. So this teal thing here is a 4-degree polynomial that matches the few points that we measured all in this spot here. And yeah, you can see that that is the case because around P, this 4-degree polynomial lays on top of the sign. So it's a very good approximation. Yeah. And the idea is now that knowing that approximation, we are going to accelerate really fast, and I'm going to drop directly to this minimum here. Now this is the real minimum, as you can see. Taking careful little steps is super much slower than just saying, yeah, well, at the level of a 4-degree polynomial, the minimum is there, so I might as well boing, jump here. And then we find that we are there, but at the moment that P is here, we have this measure point and that measure point, and then it's going to approximate it with something that has a minimum here already. So very quickly it finds this minimum. However, that's not what I'm doing yet, because I'm working on that. What I'm currently doing is, and it doesn't draw that, sorry, but it approximates it with a parabola. So actually, this is the approximation that it founds as a 4-degree polynomial. But without drawing it, it also has an approximation with a parabola. So it's probably looks something like this. And the parabola, of course, does not have a minimum. Therefore, it doesn't know where to jump to, because it just goes to minus infinity. So every time I press my space, it's going to go further down. And then a little bit more and more and more and more. Yep. Until it reaches this bottom. Even with a parabola as approximation, we can still find this minimum. But like I said, I'm working on jumping to this minimum. Now, how can I find this minimum? It's the bloody minimum of a 4-degree approximation that I calculated. Well, then you have to find the zero of the derivative of that. So this purple thing here, or whatever the color is the derivative of this 4-degree thing. Yep, so you see here, here it is horizontal. And that corresponds with the fact that the purple thing goes through 0 at this point. And it goes again through 0 here, because, well, it's also horizontal here. So you have a minimum where the purple one goes through 0, and you have a maximum where the purple one goes through 0. And then here we have the minimum that I want to find. Yep. So what I really want to do, I'm working on that, is that this P now jumps to the W value that belongs to this minimum, aka the W value that belongs to the 0 of this third-degree polynomial, which is the derivative of this 4th-degree approximation. And my attempt is, I mean, there are formulas for it, but in the end, I have maybe something that is way more complex, I thought. I'm kind of anticipating that maybe I want to work with even higher degree polynomials. So I thought, well, what I'm going to do is, I have this 3rd degree, and I don't want to drag out the big formula to calculate the exact values of the zeros here. I'm just going to do a long division of this polynomial with the 0 that I find at the moment that I actually reach one. So okay, now I'll explain once we reach this 0. So I'm going to hit a few spaces. So the P is going downhill very slowly at first, but then faster and faster, because it gets impatient. And now it overshoots. And now the next step is that we are really very close already. So in this case, now we are at a minimum. I'll do one more. So now we're really in the minimum. So I know that this is a 0. Yeah, this value of W that I now have, because I draw this P. I have this 0. and I have the exact coefficients of this third-degree polynomial. Therefore, I can divide this third-degree polynomial by w minus this 0. And that gives us a parabola, a second-degree polynomial, that should have zeros in the other zeros. So there and there. But now I did draw it. It's this blue line. As you can see, the blue line is not going through that 0 and that 0. So that's what's wrong at the moment. And I don't know why it isn't. Why it is not going through that. Now one reason could be, I'm not printing this, huh? Nope. I think I'm super accurate already here in the 0. So I really have no idea. If you have this third-degree polynomial and you divide it by w minus 40 something. What is it? 46, 47? What's that here? 47. Then, of course, I should get something, a second-degree polynomial that is 0 in the other zeros. This is impossible. It is not 0 here and here. So yeah, what went wrong? Now, if it would not go wrong, then the blue line would have gone through this point and through that point, allowing me to very quickly find them, because this second-degree polynomial I can very quickly find the zeros, of course. So my next step would be to solve or to find the zeros of the blue parabola. With that, find this 0, which is then equal to this maximum, and then jump there. So it found this one, and now we can jump immediately to this point. And at that moment I have, again, no, we don't have a 0. We jump here, and then we discover that it isn't really a 0. Because the next approximation is gonna go like, well, we're actually here then. It's gonna go like this, and then I see the zeros more or less there, so I jump there. And then by the time I found the real 0, then we can jump to the next one. Because then you have the repeat of this. So it's gonna take jump over 3, 4 to find the minimum, and then again 3, 4 to find the maximum, and again 3, 4 to find the next minimum, and so on. That's my idea. Now the current problem is that if I divide this third-degree polynomial by w minus this 0, then it doesn't work, because it definitely should be 0 here, and it isn't. Why on earth isn't it? Maybe my long division is just not working. Maybe I should just work it out, check if it is correct. Which means that I should print it. I print approximation and the derivative, but not quotient. Let's do that. Well, if he left, then this is the reason why I never explain things, because every time I explain something, then I don't know, people just go away. On the other hand, I currently have 8 viewers, so maybe the people were interested, other people, about the explanation. So I want to print the quotient as well. Where does my quotient come from? Yeah, the out, DC, notice, quotient is, oh yeah, there, okay. It's yeah, you know, derivatives and polynomials and stuff like that, but it's not that hard, but I guess you need to have studied it sometime, somewhere. Some people are really afraid of mathematics. As a game developer, I expect you to know that this math. You should be very familiar with linear algebra, no? Yeah, I have to go to the minimum to have a chance to get something accurate. Okay, so it says here that why not go even one step further? I mean, you see, the point that we found here, where the value of W, where this approximation has a minimum, went from 47.1238 to 47.1.39. So yeah, it's totally 100% accurate, this. And as far as I know, it's like 6 digits precise now behind the. It kind of accelerates, I think, the weight, the accuracy with which the approximates it. So this is definitely a 0, down to a lot of digits. And then we divide this third degree by W minus this value, and then we get this. And apparently that's not correct, yeah? Because again, the blue thing is not going through the zeros here. So I should be able to look at the numbers and I'd say, yeah, that's not correct. Let's copy this. And then just multiply it out, I guess. I hate to do this, but I'm not using that anymore. Toro. What's up, man? What do you mean, you again? I never left. Oh, yo again. Yeah, you returned. I get it. Oh, shit. And that value. I want to calculate W minus that value times this. And we have applications for that. So anyone with Mathematica who can help me out? I'll just ask ChatGPT to tell me how to do this with Octave. Oh, brilliant. It even tells me to load stuff. Yeah. Very accurate. Very, very accurate. So the highest is first. Start with the 3. Oh, I can quit here. That. So according to Octave, that is equal to this, where this is to the power 3. To the power 2. And then that's it. And I don't need this accuracy, and I'm afraid that it is almost exactly correct. Pop, pop, pop. Oh no, this one is different. So this value is correct. I think. I mean, the minus sign is correct. The digits are correct. Okay. 1, 2, 3, 4, 5. It's exactly correct. But this one is not correct. I think my long division went wrong. Well, I think just clearly wrong, because this is calculated back. Yeah, no, it's not correct. Period. Totally not correct. Well, it helped. You laughed that I used ChatGPT, but it went faster than when I had done it manually, I think. Okay, so my long division code is just simply not working. It is simply not working. So I have to have a better look at my long division. Yeah, the long division is what it is called. See the link in the description to Wikipedia. Long division. Well, this thing sucked. I added a link in the description. And it's also described here. Is what I'm attempting to do. Apparently I'm doing it wrong. Well, no better test than to just do exactly this, I guess. So I'm going to define this and then divide it by w minus 2. And then see if we get this out of it with the remainder of 62. Third-degree polynomial. Don't you love integers? But, oh, fuck. I think I already understand what is wrong, actually. I think I forgot to negate the z value. I think I'm just dividing it by z plus 2, if you get what I mean, instead of z minus 2. Yeah, well, it's not a human interface. I'm totally happy with this. Well, you can rewrite it. It's open source. Do pull request. You know the drill. Octave. Let's not use GDB. Just the printed. Oh. I think I went too far. Of course I went too far. Or actually I didn't really went too far. We don't have enough coefficients. This thing has clearly it's not a third degree. It's well, this is a third degree polynomial. We have 4 coefficients. See, it was good to quick test. And there it is. Yep, totally agree with that. That's what I just typed. And I keep getting here. Okay, okay. And then you want to print p dot the long division, I called it. I should just call it div, I guess. The minus 2, yeah, it's just a minus sign, man. Everyone knows that it is just a minus sign. It's not called P. X is the actual symbol. Let's keep calling it W. Moses, hard work. Decades of hard work. When I wanted to learn a fighting sport, I did, quite a while. You say that in English, karate. And at some point I also wanted to learn Aikido. It's said that it takes 10 years to, even become a little bit good at Aikido. And then if you begin, you really have the feeling, wow, 10 years, is it worth it? But by the time you get as old as me, 10 years is nothing. I look back, I had a decade there, and a decade there, and a decade there. And I could have learned a lot of stuff. But the only thing I did learn is programming and mathematics and electronics, actually, and physics. No, okay, I like I said, I think I did, I can't remember, at least 6 years, maybe longer, karate. So some kind of, actually it wasn't really karate, it was like a cross between boxing and karate. Kickboxing-ish. And a few years Aikido. Anyway, the things never come in... it's always years, If you haven't done something for years, then you're a hobbyist. And still Kotaro is telling me that I'm doing it wrong. Well, he's right, of course. I'm just not influenced by it. I just laugh it off, even if he's right. What is the problem here? Non-const LVL reference of type double cannot. Oh, that's my remainder. What am I doing? Double remainder. Now the remainder 14 clearly shows that it did not work. Don't have need to look at that. So my guess was that I just mistook the sign of this thing. So I use -2 and then it probably works. Nope, no, the remainder is 46. It's even worse. Something is really wrong then. Although the 11 is now correct. Oh wait, this thing has a remainder. Yeah, but not this. And the 11 is now correct. Okay, let's see. So what happened here? We multiplied this with w plus something, then you get 3 times w to the power 3, of course. And the something is multiplied with the 3. And plus 11, right? Why is this so difficult? Maybe this is correct. Maybe this is correct. I just did it wrong in the documentation or in the comments. So what we get now is this. So the 26 would be wrong. Yeah, I think I've got this minus here. What's a minus here? That is -4. What is subtract? -4 plus 22. That's 18. 22 minus 4, it's 18. And then here I get 18. That is -30. This minus, no. Wait a minute. 10 plus 36. Yeah, 46. So this is correct, and that was for I mean, what exactly is this now? If I multiply this with W, I think -2, right? So that is this whole thing multiplied with W. W. Da, da. And then -2 times this whole thing. If you multiply that out, you get -36. I don't like this minus. And now we have minuses here. Duh. Okay, -18 gone. -36. Minus 22W. And then plus 6W squared. I hope I didn't make mistakes. So that would be -36. And then we have 18 minus 22, that is -4 W. And 11 plus 6. Uh-oh. Must be -6. Yeah, you're right. Maybe even the 30 degrees too high. Because I keep making mistakes. Or the whole -2 was a mistake to begin with. You've gotten rid of all the minuses completely. So -2 times something. Horrible, horrible. Okay, I made a mistake. I'm gonna go again, or I can use Octave if I knew how to do that. What is faster, multiplying this by hand or? Come on, I'm gonna try this again. First of all, I'm going to reverse this because now suddenly I can't work with this. Plus 18. 18, 11, 3, yep. Multiply this with W. And then -2 times that. I'm not going to do that directly, right? So that is -6W squared. Yeah, now we get 5. -22W. That it becomes -4. -36. And then I guess if we add the remainder to that, we get a +10. So this is correct. So it gave me the 0, 2 if I pass -2. Yeah, so I think that's the whole problem. I just pass, I want to pass the 0 itself. So now I want to pass 2 and then get the same output. So I just have to negate the Z usage. So this must be a plus. Yep, so this is now it's correct. So that was the whole thing. Okay, so let's yeah. So it does work now, huh? Well, like literally losing half an hour over a minus instead of a plus. Very annoying. Okay, now it works. At least I see everything go through the 0, 0, 0, 0, 0, 0. It's not bad, you know. I think the blue thing here crosses there, and the purple on there. That's close enough. Totally, yeah. Again, they both cross more or less at the same point, which is already amazing, if you ask me. Because we're not even close to the minimum now. Okay, here it is off-ish. Definitely off. Or maybe it was outside of the screen. I don't know. This one crosses definitely in through 0 at the right point. Even now, LP is not even close to the minimum. And here, the minimum is here, but okay, I think the blue one crosses here. So though here, this is what I can work with. Just even in the light of inaccuracy, you still, you know, get where you want to be. This is good. And now it's already pretty exact. I think I'm gonna multiply blue with some factor, because it's hardly to see where it crosses. Let's make multiply by 10 or something. Now it's exact. Very good. So now we get the zeros of the blue parabola. They go through the, well, they give me the zeros of the third-degree polynomial already. So I don't have to use the horrible formula for that. So now I want to see when it detects it. So only now the minimum is reached, which is, we already have problems with calculating stuff. Now the 0 is here, that it's like over the top. Maybe a bit too much, you know. think the detection definitely should be sooner. Let's say I have we have 3 points. Maybe I should simply stop if the last 2 points are vertically at 1% of the other distance. Is that reasonable? Well, it would already be here. No, that's not true. You accelerate. So it goes faster and faster. So the last 2 points, I'm gonna show the last points. So extra work, but hey, it's fun. So we have a point plot P, but really, chess works. I can now make. Let me show you. Go file. So this is what I write now. You have this is my A4. If I put an A4 on my monitor, it's exactly this size. This is exactly one on one. How on my monitor anyway? How the A4 looks like. And this is of course very sharp because it is scalable vector graphics. If I print it, it looks beautiful, and I can zoom in theoretically, basically. So yeah, it works. I think I want to add my my plot point to the history instead of here. So that would be, I think, create point returns a point, obviously, and create text returns a text thingy. This is a point. Create text returns text. And here's the history, so I can just add it to the history. Yeah, I typed it in HTML. It's in on GitHub. I just committed everything. So you can look in the repository. Link in the description. In the chess directory. Chess lessons even. Chess/lessons. Okay, man. Thanks. See you around. Yeah, the point is just W, LW, which I'm both passing. Maybe I should not add a label. I have 3 of them. Oh yeah, theoretically I should add a label that is the digits, the current digits. But it rotates around, that is also not interesting. Let's keep a counter then. So I do have to pass the counter then. And now I'm going to move this to the data. And then the label becomes, create text takes a string, I guess. Or text is just a string, of course. So let's do standard to string. N, where N is being passed. And here I'll already call it W and LW. Literally, yeah, that works. Except that now I have to store these things in the data object itself. So this is a point. I guess Cairo window point. P. Text. P label. Boy. Point. Cairo window point. Is that this one? Yeah, well, that has a default constructor. Because text doesn't have a default constructor. Nope. No, sorry, it's returning a plot one, of course. I can construct, I think, a default constructed plot text simply by leaving the shared pointer empty. You just need a default constructor then. Yeah, well, for this one too. Default constructors are, well, almost always necessary, aren't they? Well, this gives me the default constructor as well, so that should work. And then I want to test, yeah, the other one as well, I guess. Well, the plot point is already explicit, has one. Okay, whatever. No, wait a minute. Yeah, no, hold up. Plot point. Plot or plotted. And then nothing compiled anymore. Default constructor implicitly deleted because position has a pixel. What a whine. Why are we whining so much? If someone wants to use uninitialized memory, I won't stop them. That's why it is C++. I think something went wrong, didn't it? Use of undeclared identifier plot. Right. Now you're telling me I have to pass the plot itself to data. Seriously. Okay, plot is what? Plot is plot. Just pass a reference. I guess grade point is not const, and so on. Nope. So let's pass Cairo window plot reference. Is je first agreement? This still fits, right? No, yeah. Can might as well do it log the line. And layer. And the layer. Okay, now it starts to be clear. Well, clear, not clear, but it starts at the very least. Alarm bells are going off. I think I should just pass these things here. Enough is enough. This is no longer necessary. It's just a point. I'm gonna get recreate a point. It's just a hero. Yeah. It's a base class basically. Let's just recreate it here. Create text is ambiguous. What is the difference? Create text. Layer, style, position. Text. Layer, style, position, text. I'm not telling it what it was. Yeah, okay, whatever. I think that is automatically point then. Point P. I think it's making a copy, isn't it? I'm suddenly not feeling very certain. This thing is going to be destructed, so let's not store references by accident. Create point is taking by reference a point, but then it makes a copy of it. And then that is used. So yeah, guess copied again. It was already temporary, so. No worries, I suppose. And this even takes it by value. Okay, so no problem there. So W0 is a point there, and then I hit space, and now we have no one. And again, still no one. But this keeps repeating 0. It's probably because I never increment in. I think the whole learning rate is starting a little bit too slow anyway. And I want, of course, to increment in. Yeah, do you see the 3 points that are in the history, aka the 3 points at which it bases the approximation, the Thiel fourth degree polynomial approximation of the sign. Okay, I never saw that before. Oh, that's because I changed the learning rate. Yeah. It jumped all the way, yeah, all the way here. Last you had an overshoot only until this point. Okay. It will go back. 11. Oh, okay, definitely a little bit too much then that overshoot. And then now finally by coincidence it gets, doesn't overshoot again. That's interesting. I should adjust the learning rate. While I'm going downhill, I accelerate, I increase the learning rate, double it every time. But as soon as you overshoot, aka hopefully at least, the slope is going down. Or maybe I should look at the value as well. Either, if you jump from here to there, the slope is still going down, but we are higher than we were before. So that's also, I would also consider that as an overshoot. And then maybe the best approach after an overshoot is, yeah, good question. If you work with parabolas, the learning rate was way too high in this case. I think I can limit the learning rate. I can limit the learning rate to the inverse of beta, which is the ideal thing to jump to the actual minimum. Ah, yes. If it exists, right? Did it still not exist then? Wait a minute. It's an interesting thing. 13 is now here. 14. Now it goes on. 15? What? Oh, and it's on the left. I think 15 is here. 13 is here. Okay, so now tap again. Oh, this already. Now 13 is here. Okay. Then do it again. Now it disappears because the accuracy is already 6 digits. I don't know. I don't know. Okay, so it went twice as fast. And then again twice as fast. You would say, well, it's maybe somewhere here. And then again twice as fast, or somewhere here maybe. And then yeah, okay, good enough. Okay, with these 3 points, the parabola, I should draw the parabola. The 4th degree thing is looking excellent, of course. The minimum is absolutely there. Yeah. I think the parabola is still having a maximum here somewhere through these 3 points. And then it doesn't know there is no minimum here. It doesn't know anything about a minimum. And it just keeps accelerating like crazy. Yeah, this distance is like already way too fast. But yeah, you can't know that as long as you only see the parabolas. You can't know it. You don't know. Or do you? What is wisdom here? I think you have a problem. Or not. if you ask me, the derivative here is like, well, whatever steepness it is, and here less steep. So that should tell me that the parabola is going like this. I'm gonna draw the parabola because I have no clue what my code thinks that is going on. Yep, I think I got it. Well, at least an attempt. I'm going to set the learning rate back to the beta inverse value as well. Like hit the brakes. Nope, that didn't work. Jesus, it's only going faster. Because it's bang! What the hell? Okay, we got lost. it found a minimum outside of the graph. Damn it. Yeah, I deleted that. Oh, there's a new file. Yeah, well, okay. Yeah, it's just bad inverse. Bad inverse. That should be correct then. Yeah. Okay, it seems like a new problem or a separate problem. I don't want to deal with it right now. I'm just gonna go back to 1/10. Yeah, what I was going to do was draw the parabola. That's what I was going to do. Well, that's a very interesting approximation. Oh, I get it. Oh. How do I find that? Hmm. Hmm. Yeah, I don't know. So the red line is its best approximation at the moment. And that is a parabola, but it's not really clear to me where it thinks that the minimum is. But I think the minimum is at the top here. So this goes to minus infinity, and this goes to, well, to maximum, and then downward again. Probably. Therefore, it just keeps accelerating. And jumps to 12. But now, as you can see, is the parabola, is this red thing here, is very, very accurate. So we should jump there now. Yep, that's what it did. And now it's even more accurate. Okay, this is what it usually does. And then we get minimum reached. A little bit too late, if you ask me. Now, okay, now we have it. All points are here. All 3 points. Super close together. That's not nice. That's not nice. But why is this too close together? Because we want to jump. Yeah, there is something, which is, of course, if that is 1,000,000 times larger than the spread of these points, then something is wrong. That gives me an interesting indication. I could have I could calculate, say, the distance between these 2 points. And then stop if the spread becomes like way too small compared to that distance. Hmm. Yes, yes. That is what I'm going to do. The distance between these zeros. That is a good measure. That is a very good measure. Let's print the zeros. They're all like every step. So I already have the quotient calculated at the moment. think I need to keep the overshoot in. Good, now I want to jump here. And then I have one new point, and then I think I should use the points that I encounter, the closest 2 points from the whole history that I encounter from going this way. So we have a point here. That's the overshoot that I have. Well, okay. So we go back. And then we found a minimum. Now 12 disappears, which allows us to detect that we have R in the minimum. It says minimum reached. And now I should use, I think, this point. And then the last point that we have here in the minimum. And then this point, because, well, it's just way further away than The last two are super close together here. Hey, custom. Together with this. So now you have this point, and this point. But it should also switch away from the minimum to, I mean, the next zero. And so it knows that it is a maximum. I think I should really switch to trying to find the maximum here. No, I'm not. I'm gonna switch to the... No, I'm not. Wait a minute. Or maybe I am, actually. The whole sign thing is a bit stupid. Maybe I should add a parabola or something to it. So there's a clear minimum. Let's make A larger, so I see a little bit more. I should just shift it actually. Let's do A plus B times W. No. Let's try this. It's too much. I want to see 2 minimum. I don't need to see this one. Maybe I do. Yeah. Just shift it a little bit further. I have no idea which way I did shift it actually, but I want to shift it an additional 10 points. No, wait a minute. 10 is this. 5. But which way? Damn it. A. Let's add 5, see what happens. That was the right way, yep. No, it wasn't. And I'm going to add something else. No, wait a minute. I'm going to add a parabola with a... Okay, now I first need to know where my minimum is. No, let's take this minimum, which is at 50, I don't know, 57 or so. Jesus, why am I always ending up there? Plus the square of... That probably doesn't work. Or does it? I don't know. Maybe it doesn't work. The square over W on minus 57. But I keep using symbols, I think. X. Yeah, otherwise I can't calculate the derivative. Or can I? No, I might as well use a constant. The reason I'm not using constants actually is because my constants must be rationals and I wanted to use floating points. So I'm using symbols which I don't just assign. But yeah. Could make rationals of these things, of course. Hello, Musa. Amas. What is with the H Amas? Your name is Musa Butuatu. I don't think you pronounce it like that. Or is it? Is that your real name? Instead of the YouTube name. Usually I'm politically neutral. Whoever comes, but Hamas is not my thing. No, definitely not. But I guess it's not related to that, is it? Yeah, free Palestine of Hamas, yeah. Kill them all. This did not go well. I think I need an incredibly large... No, incredibly small factor in front of it. Oh, the opposite. The opposite. I'm totally neutral, but in this case, I'm very anti-Hamas. For obvious reasons, I think. This war cannot end until they killed every Hamas member. It's just a fact. I mean, you cannot tolerate bullying for decades long. They went too far. They're crazy. It's just completely insane people. Probably still not large enough. Yep, this is nice. We have a local minimum here and then a real minimum here. But this is not even close to any polynomial because there's a sign included. I'm doing C++. Okay, let's not talk about politics. Talking about, I should stop and go to bed. Yep, I think this is nice. Now we can start here maybe. Well, say start at -2. Well, that's better. Oh yeah, of course, we still have a point here. Very good. So now it should jump here and then find this maximum and then find this minimum. Yes. I don't know. I'll do the Z minimum and then one overshoot, I guess. So I just should remember the overshoot. As soon as you have an overshoot, store it. Or it is also possible that I want to go that way. I don't want to go this way at the moment. So yeah, I should start here, I think. That's more interesting. 30. Let's start at 30. Or even higher. 30, 32. Let's start at 32. See what then happens. So the real minimum is here, because we start on the hill on this side. It's going down here, of course. Hey, yay, gradients. And then we get an overshoot. And oh, those clearly the derivatives change sign, so now we have to go back. And then go here, and now the 11 is removed, because, no, the 10 is removed. I replace with the 13 here. And that says minimum reached. And now I don't want to use this 11. I want to go that way. So now it's going to find the 0 of this parabola here, this one and this one. Calculate the corresponding values. Maybe directly this, or shall I just use that one? I think let's just use this one. It's faster. So then we see that this point is lower than that point. Therefore, we want to go that direction. Therefore, I need my 10, which is not overshoot. Ta-da. I just need a little bit of history, but not that much, I guess. So you have one overshoot, so the previous one, 11, 12, 13, yeah, makes sense. Should not necessarily have happened. It could have been that even the 11 had to be removed, I think. They need to keep some history. Actually, I had quite a lot of history on this side. If I now go here, yeah, I just want to go the other way. That's the whole point, I think. So now we found the minimum, and now we want to go that way, finding the maximum. But I'm going to do that tomorrow. We'll start working on that tomorrow. I'm having the feeling that this is not going to work in a multi-dimensional case, however. Well, I mean, a minimum in a multi-dimensional case is, yeah, just really a minimum, you know, whichever way you go, it increases, but a maximum like this, does that exist as well, locally-ish? I mean, it could be a whole ridge, a mountain ridge, not a clear top, but more like, yeah, I don't know, an area that is higher. The reason I'm going this way is because it's horizontal here. So yeah, that indicates that afterwards it's going down. So it's very interesting to go there, because who knows, there is, you know, some deeper point after it. But in the multi-dimensional case, I don't know. I feel coming that I can't sleep again. But last 2 nights were bad because I keep thinking about this. Let's play a game of chess. this pawn or this bishop? I think the pawn. Hmm. I should have played faster, because I think the reason was that he wanted to play the knight here. I could just take the pawn. And I take my bishop and I take the queen. Okay, now the pawn came. So he wants to pin me or go here. My bishop is kind of undefended. But now I can just go here, no? And then yes, I take with the pawn, or I don't know. Or the bishop comes. Just castle. Yeah, this is still. Oh, it doesn't do it. Okay. I can take and then. He has to take back with the pawn, I think. And then he takes that thing. I have to take anyway, otherwise he takes here, and that would be bad. Yeah, why not go here? Why did this guy not castle? You play the bishop like 1, 2, 3 moves. And then get it exchanged against my knight here. This knight is definitely going there, yes. So if you do this, he's going to castle. And then I can chase the knight away or not? I think so. He wants to push this as well. So what happens if he does not castle? I attack it. Yeah, it still has to go. It's a bit vague, but yeah, I don't know. Why not put my knight on his half in the center? What more can you want? Is there anything more in life that one can want? He sure is thinking a long time. A very long time. As promised. No, I should have taken with the bishop, I guess. Because if now he does this, then yeah, okay, I'll get an open H file. I would get an open H file back, so. Yeah, that's true. I should have seen that one coming. Damn it. My knight is attacked now. Oh shit, give this pawn away. Ah, yeah, it should have gone one down. No, wouldn't even have mattered. Damn it. Way too many pawns down. Way too many pawns. Shit. Should we play this one? Do we still get the chance? Nope, we don't. Fuck. Yeah, now we get that, of course. Ugh. I get a pawn back, that's nice. He's still +1 and +1. Yeah, you could have done that sooner. Oh, fuck. Nah, just resign. Shit. I think I wasn't even that bad, really, before I gave away the bishop. Yeah, it's a draw. I just wanted to stop the king from coming here. Yeah, I can go for this pawn. I just can go for this pawn. What would he have done? Maybe this, and then I attack, and then I win. Oh, wait a minute, I don't attack. Now I win by walking. Oh, I can attack those two. Yeah. I had all the chance in the world, man. All the chance in the world. Oh, wow, yes. Very good. Yeah, totally winning. Totally winning. The position was a draw, but errors could have been made. So stupid. It's a time pressure. Time pressure, too much time pressure. Okay, I'm going to bed. Good night, everyone. And if Ninja is still here, shame on you. Damn it. No, he's sleeping. He better be sleeping. So like a whole night without sleep if he would still be here. So But he never said good night, so yeah. Yeah. Tomorrow. Ding, 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 ding. At least I have a lot of polynomials that look pretty cool.